one of the key things that we do during a DDoS attack, besides reactive things like black holing, the destination, which effectively completes the DDoS for the attacker. We like to be able to do better than that. We want to be able to filter that traffic more intelligently. So sometimes we can do things with access lists, and the best place to put an access list is on your ingress perimeter. So in order to make that work, though, you've got to touch a whole lot of routers, especially in a network our size. One of the fun things I like to say about AT&T is that we don't really do anything different from anybody else. We just do a lot more of it. It's just a lot bigger. So, in order to maintain that security perimeter around the edge of the network, there's a lot of places that you have to touch. And depending on the scale and scope of your network, there could be different vendors involved. That adds to complexity of maintaining that perimeter. So some real smart people got to thinking about how can we do this a little bit better. And if there were some way to transport access list information in some protocol and provide that to those edge devices, then those edge devices could dynamically update those perimeters without having to go in and touch each piece of configuration on each router. Turns out we already have protocol sessions established to every one of these routers, BGP. So they got together, they started thinking we can do this BGP flow spec. Instead of distributing routing information that tells you how to get to a particular prefix, we can tell the router what to do with a particular prefix, similar to what we do in an ACL. We can match on network, on prefix, mask length, packet sizes, port, protocol, all the basic things that you can match on in an ACL. And we can also do things like they have different actions like accept, drop, modify the next hop. There's even some VPN-based things where you can route the traffic into a particular VPN. So there's all sorts of really nifty things. And the really slick part about it is it's all carried in a new address family over BGP. I say new, it's not really that new, but the router vendors have started implementing it much more widely than has been previously the case, relatively recently.
So let me see if I can paint the picture a little bit here. Perhaps we have a customer, they're under denial of service attack, and I think we, as you're well aware, we have a DDoS protection service. So we don't really have to just black hole them. We can send the traffic to a scrubbing facility and to scrub those packets out. But I think perhaps what you're talking about allows us to expand that capability to be able to selectively route traffic into the scrubbing facility and perhaps to selectively block traffic right at the perimeter. Do I have it about right?
Exactly. So once you get your network set up to the point where you can push that traffic into a VPN, an MPLS VPN to direct it to the scrubbing facility, then you can use that. Yes, you're absolutely right. You can more granularly divert the traffic to the to that scrubbing facility, and then also, you can, if there's some piece of traffic that that the customer never ever wants to see. Say you've got a web server that you're protecting. You don't want to see UDP 123 coming at that server from the outside. So you can just block that right at the perimeter. Don't even bother sending it to your scrubbing facility, and just save that bandwidth right there.
So it provides a lot more flexibility in how you can dynamically control things on the network itself and allow the scrubbing to focus on the things that where you really need something above the network level.